All right, let's do some examples of graphing linear equations. Before we do that, we need to write down a definition, and that is a linear equation in two variables. A linear equation in two variables has the form ax plus by equals c. A, b, and c are numbers. The x and the y are the variables. This is called standard form. For a line. When we graph these, we always get lines. There are other forms, though. There's a slope-intercept form and point-slope form. That's in a different section. So for now, we'll see a few problems in standard form. Example. Is 3, -1, the ordered pair 3, -1, a solution to 2x plus 3y equals 6, question mark. That's supposed to be a 6 there. Well, if it's a solution, then it's supposed to make the equation true. Now keep in mind that for an ordered pair, the first value is the x and the second one is the y. So what I'm going to do is I'm going to plug those numbers in for the x and the y and see what happens. 2x plus 3y, is this going to equal 6? If I plug in the 3 for the x, right there, goes there, and the -1 here for the y. If I work this out, this will be 6, that will be -3. Does this equal 6? The answer is no. And so 3, -1 is not a solution to 2x plus 3y equals 6. Well, there actually are infinitely many solutions to 2x plus 3y equals 6. Here's how we can find some. We just make a table of points. Pick an x and you find the y that goes with it. For instance, if I start with x is 0, and I plug 0 in here for this x, and I were to solve that equation for y, I'll do it down here. 2 times 0 plus 3y equals 6, 3y equals 6. Y equals 2. So 0, 2, the ordered pair 0, 2 is a solution to the equation. And I can get more and more solutions. Just pick a different number for x. Let's say if x is 1, if I plug a 1 right in here for x and I work that out for y, I'm going to get, I believe that would be 4/3 if I work it out correctly. If I plug in a 3, let's say, 3 in there for x, that would be 2 times 3 plus 3y equals 6. Move that over there, it's 3y equals 0. Y is 0. 3, 0 is another solution to the equation. And we could use decimals, fractions, and so on, get in as many solutions as we want. Why don't we go ahead and graph these right now. By the way, in case you've forgotten, when you have an x and y coordinate system, this area here is quadrant 1. This over here is quadrant 2. Down here is quadrant 3. And over here is quadrant 4. 0, 2 is right here. 1, 4/3 is right about there. 3, 0 is right here. Notice that the points are forming a straight line. And they should. All of these equations we'd see in this section should give us lines when we graph them. If one of your points was not lined up properly, then most likely you made an error. And we could put in one more here if we want. Why don't we go with, put in a negative number for x. What if x is, let's say, negative 3? If I plug -3 up there for x, I get 2 times -3 plus 3y equals 6. If I move that over, that's going to be actually 3y equals 12 and y equals 4. So -3, 4 is another solution to the equation. Let's plot that. 1, 2, 3, 1, 2, 3, 4 to be right in this area here. Notice that they all line up. And if let me try it here. Let me draw as straight a line as I can. There we go, and I've graphed the line. Okay, so every single point on that line represents a solution to this equation. There are quicker ways of graphing lines. Some of you may recall slope-intercept form and do this rise over run sort of thing. That's coming up in the next section. This is sort of the simplest way, or I should say the brute force way. You just pick an x, you find the y, and you just plot points to get your line. Notice that right here, this point where it crosses the x-axis is called the x-intercept. The x-intercept for this line is located at 3, 0. And up here, this is the y-intercept, and that's located at 0, 2. Okay, so one way that we can graph lines a little bit quicker is just to find the x and the y-intercept. Let me give you an example of that. Let's say we have 4x minus 2y equals 4. Okay, there's our equation, and we want to graph this line. What I can do is I could just find the x-intercept, and then I'm going to find the y-intercept. Now to find an x-intercept, what you do is you set y equal to 0. So if I plug in 0 there for this y, and I were to solve for x, I would get x equals 1. And so the x-intercept here is located at 1, 0. It's the x-intercept. To find a y-intercept, what we do is we set x equal to 0. 4 times 0, I'm putting 0 in here for x. 4 times 0 minus 2y equals 4. Now I'm going to solve this equation for y. Negative 2y equals 4, y is negative 2. So the y-intercept for this line is 0, negative 2. Right there. Y-intercept, and up here is the x-intercept. And really all you need is 2 points to draw a line. One 0 is right here. That's my x-intercept. 0, negative 2 is right here. That's my y-intercept. My line must look like this. If you wanted, you could plot other points to check your results. Let me just pick one here randomly. Let's say x equals 2. If x is 2 and I were to plug it into the original equation, 4 times 2 minus 2y equals 4. And I were to solve this for y. Let's see, that's an 8. Move over there, that'd be negative 4. Divide, positive 2. 2, 2 is another solution to this. And 2, 2 would be right there. Notice that it would fall right on the line, as we would expect. Okay, so one way to graph a line is just to find the x and the y-intercepts. Let's do one more example of that, actually. Let's take x minus 3y equals 5. Okay, and I'm going to find the x-intercept. Remember, to find an x-intercept, all you do is you set y equal to 0. Let me fix that. So if I plug 0 in here, I get x minus 3 times 0 equals 5, x equals 5. So 5, 0 is our x-intercept. Let me plot that. Right there, 5, 0. Okay, now I need the y-intercept. To find a y-intercept, we set x to 0. I'm going to plug 0 up there. 0 minus 3y equals 5. If you were to solve this for y, you get to negative 5/3. Y-intercept, 0, negative 5/3. Now, negative 5/3 is about, what is that? Negative 2 2/3. So that would be right about there. And our line must look something like this. And I've graphed it. Let's try another. Three x minus y equals 0. Okay, let's find the x-intercept. To find the x-intercept, we of course set y to 0 as we've done the last couple times here. If I make y 0, I get 3x minus 0 equals 0. X is 0. So this line goes through 0, 0. Right there. Now if I try to find the y-intercept, I would just get 0, 0 again, and because this is actually the x and the y-intercept at the same time. So that won't do me any good. I really don't have much choice here. I just have to pick another number for x and plug it in. So really what I have to do is resort back to my table of points. Picking a number for x, I'll just pick 1. If I plug 1 in there for x and I solve for y, I should get, let's see here, 3 times 1 minus y equals, that'd be y equals 3. So it goes through the ordered pair 1, 3. And you could plot some other points if you want, but this will be enough. Our line looks like this. Should go through 0, 0 there. Let me fix that. See if I can fix that. 1, 3, and yeah, a little better. Okay, there's our line. Now for a couple special cases. Suppose we have the line y equals 2, or the equation y equals 2. Notice there's no x in the equation. So if I try to plot points, or make a table of points actually, if I pick a number for x such as 0, well the equation tells me y equals 2. If I pick x equals 1, the equation up there tells me y is 2. If x is negative 1, y equals 2, and you get the picture. Y is always 2 no matter what you pick for x. So if we were to plot these points, what we would end up with is 0, 2, oops, there's blue there, red, 0, 2, 1, 2, negative 1, 2. We end up with a horizontal line. So a good thing to remember is if there's no x's in your equation, it's just y equals some number, you're going to end up with a horizontal line. Let's now say we have x equals negative 1. Well, if I kind of have to do this backwards. Let me pick a y. For instance, if y is 0, x is negative 1. If y is 1, x is negative 1. If y is 2, x is negative 1. No matter what I pick for y, x is always going to be negative 1. If I plot these points, then we end up with negative 1, 0, negative 1, 1, negative 1, 2. We end up with a vertical line. Vertical line. So a good thing to remember here is if there are no y's in the equation, it's just x equals a number, you should end up with a vertical line. Okay, and that's our quick little lesson here on graphing lines by plotting points.